Today's set of notes we are going to learn how to write the atomic symbol. And when we think about the atomic symbol, we have to understand three things about the atom. We need to understand the atomic number, which tells us what element it is. We need to understand the mass number, which just tells us how much mass that specific atom has. And we need to understand the charge, which tells us whether how much positive or negative charge the atom has. So we'll talk about these one at a time. The first one we'll talk about is atomic number. This one's the easiest, but also the most important one. So the atomic number is just equal to the number of protons. And the reason the atomic number is so important is because this number determines what element that atom is. So we have here the periodic table of elements. And if you take a look at how this table is organized, you can see that each element has a number above it, and that's what we call the atomic number. And that's just how many protons it has. So if I had an atom with 5 protons, the atomic number would be 5, and that would be a boron. Or if I had an atom with 8 protons, the atomic number would be 8, and that would be an oxygen atom. Or if I had an atom with 26 protons, the atomic number would be 26, and that would be an iron atom. So the number of protons in that atom determines the type of element that atom is. So the type of element an atom is depends on the number of protons in the atom. So that's the first thing that's really important. We have to figure out the number of protons, or another way of saying that would be our atomic number. The second thing that we said we needed to find was mass number. So mass number, if we remember our three subatomic particles, protons had a mass of 1 AMU. Neutrons had a mass of 1 AMU as well. So what we do to figure out the mass of the atom is we can just add the protons and the neutrons. If you remember, electrons had a very, very small mass, so we don't need to add those together to get the mass number. So the mass number, you just add those protons, add those neutrons, and that is going to be the mass number of the atom. And then the last thing that we need to keep track of is the charge. So if we remember, protons have a +1 charge. Every proton has a +1 charge, and every electron has a -1 charge. So they got the same charge, just opposites. Protons are plus, electrons are minus. And we don't have to use neutrons here because neutrons are neutral. They don't have a charge. So we just take the amount of protons that we have, we subtract the amount of electrons, and that's our charge. So if we have more protons than electrons, we are going to have a positive charge. And if we have more electrons than protons, we are going to have a negative charge. So something interesting here, if the atom has a charge, we call it an ion. So that's a little bit of vocabulary for you. Most atoms are neutral, so they are going to have the same amount of protons and electrons. But if there is a charge, we're just going to call that an ion. So now we're going to take these three numbers we got, our atomic number, our mass number, and our charge, and we could put those into our atomic symbol. So the way we are going to organize this is we're going to have our element symbol here. So if you remember our element, we would just use a symbol of whatever letter we got here. So if we got a hydrogen, it'd be a capital H. If we got a carbon, a capital C. Sulfur would be a capital S. So whatever the symbol for that element is, we would put that in the middle. And then we would put the atomic number on the bottom left. So one thing I want you guys to remember is the atomic number is always unique for the element symbol. So if it was hydrogen, our atomic number would always be 1. Or if we had a carbon, our atomic number would always be 6. So for whatever element symbol we have here, we're always going to have the same atomic number down here. So the next one we got is mass number. That goes on the top. And then our charge will go on the top right. So this is how the atomic symbol is organized. Another way we could think about this, if we want to just think about protons, neutrons, and electrons, is we can just put what each of these are just in terms of subatomic particles. It is important to remember this vocabulary, but if we want, we could just think of it as the subatomic particles. So this would be the number of protons. Up here we would have the number of protons plus the number of neutrons. And where our charge is just the number of protons minus the number of electrons. So what our goal is with all of this in the element symbol is to be able to do problems in which we can go from the number of protons, number of neutrons, and number of electrons to our atomic symbol, to drawing a picture of it, or any way around. So if we're given one of these, like a picture of the atom, we should be able to get the atomic symbol and how many protons, neutrons, and electrons are in it. Or if we're given the atomic symbol, we should be able to draw a picture of it and be able to say how many protons, neutrons, and electrons are in it. So all we would need would be one of these to be able to find the other two. So we're going to do some example problems like that now.